day today. Don't mess this up, Jonathan. There he is. We've got everybody. Just as the music crescendos. Perfect timing. Okay, let's get started. Good afternoon, everyone. Hello. Welcome back to an amazing week of geometry. I've got a special treat for you. We are going to do a group project. Okay, we're going to take a little break from the usual problem-solving slog, if you will. I don't know, I'm sorry, maybe you really like the problem solving. You're like, no, Mr. Apple, those were the best things ever. But wait, this will be fun too, I promise. And I would like to start with an explanation of where this is coming from. Why are we doing a project this week? Really, it comes down to too much cool stuff and not enough time to dedicate to it. All right? This is one of my favorite websites, the Polyhedra Viewer. And on this website, you can view the polyhedra. It's very well named. All of the, well, not all the polyhedra, a lot of the polyhedra. You can just click on them and open up a 3D model that you can move around and look at from different angles. Okay, here's the icosahedron, and you can go back and, that one's boring. Let's look at a snub something. What is this? A snub cube. What does snub cube mean? I don't know, but this is it, right? This is what happens when you snub the cube. I mean, I see the little squares. What's with all these extra triangles? Okay, this is a wonderful resource for just getting a visual feel for a lot of these things, finding out new stuff. Look at this square cupola. Okay, square ortho bicupola. It's two cupolas in one. I didn't even know this was a thing, a cupola. I thought that was the little fiddly bit that goes on top of a gazebo. No, turns out it's a type of geometric solid. It actually has a real definition that separates it from these other solids that are not called cupolas. I bet you didn't know that. I found that out myself when I was looking at this website just a few years ago. So I would love for you to just play around with this and just find cool stuff. In order to direct your exploration and give you something to work towards, I have created this group project for this week. Okay? All of the details can be found on this document there on Google Classroom. We'll go through the details in a bit. But in short, you'll be working in your groups. I have already created the groups. You've been assigned who is in what group already. That's posted on Classroom. You will pick one category of polyhedra. Okay, the specific list is here, all cool stuff. A lot of them you can see right here on the Polyhedra Viewer, right, like the Platonic and Archimedean solids. Okay, we've talked about the Platonic solids. You read about the Archimedean solids over the weekend. We've done some work with prisms, but not anti-prisms. How do those differ, right? What are these other things? The cupolas and the rotundas are on the list. And great and diminished, I don't think that one's on the list. We've got lots of different types to choose from there. Okay? You'll pick one category. That is your first and most important task that must be done today. Your group needs to tell me which category you've picked. You will then research and create a presentation. You will be graded on the correctness, quality, and creativity of your presentation, both by me, the teacher, and your peers. Okay. We'll go through the full guidelines in a moment. But to set up the expectations for today, this post, due Wednesday, March 3rd. Okay, so by Wednesday morning, you must have completed the following. Everyone, every group member will submit a copy draft of your project so far. I want to see that you have something. Doesn't have to be a lot. Doesn't need to be more than, a title slide, okay? But I want to know that you opened a thing and you got started. You didn't wait till the very last minute. Because the whole thing is due Friday. So I'm cutting it in half. Do you at least have something by Wednesday? Emphasis on copy, okay? It doesn't have to be, but if it is a Google slide, okay, the sharing and editing access permissions changes whenever you submit on Google Classroom. When you submit it to me, I then get control of the actual original file, and it changes the sharing, and so you might not be able, your teammates might not be able to edit it if you send in the original. So create a copy. In fact, I want everyone to create their own copy and submit it here on Google Classroom on this post, so that I know that all the team members are in unison and they are all fully aware of where the project is so far. Okay? This is a team exercise. I want to make sure you are working as a team. In addition, as part of that team process, I need you to post a plan of how you are going to finish, including, most importantly, who will do what. When you get to Wednesday night, you need to assess, okay, what do we have left to finish? We need to add this slide, we need to add that picture, we need to add this title here. Okay, right? Fatima, you get that picture. Esmeralda, you add the text to it, and Alan, you take care of the other slide, right? Some list like that. I don't care how you divvy up the work. You can do it by topic. You cover this part of the material, you cover that part of the material. You can have one person do the visuals, one person do the text. I don't care how you divide it, but you need to tell me who is going to do what part that remains. And everybody must submit a copy of that document on this classroom post. Again, so I know that everyone in the group is on the same page of what the expectations are, so that on Friday, when I go to grade the full project and I realize, hey, the pictures aren't there, Alan, what did you do? You agreed, and your group said, Alan, you were going to add the last pictures and they're not there. Right? We know who's at fault, and I don't hold the rest of the group. I won't penalize them for not having the pictures in their presentation. Okay, it's only Alan's grade that's going to suffer. All right, Alan, I can pick on you like that because I know you would never do that. Okay, any questions there on what I need by Wednesday? No? Okay, then let's talk about the specifics of the project itself. Okay, you are going to, research a set of polyhedra, right? We looked at the platonic solids. Now you're going to look at a different set. Give them the same old treatment. You create some kind of a presentation, right? That's both texts and images. I don't care what kind of presentation. If you want to make an old-fashioned poster and somebody bring it in on Friday, go for it. More than likely, since we're all working from home, some kind of Prezi or Google Slides, old-fashioned PowerPoint. If you want to make a video, whatever, right? Electronic form is perfectly okay. Just, if you're going to do something slightly out of the ordinary, let me know. You've already been assigned your groups, so they fit within the color groups there. These are the categories to select from. All of them are awesome, okay? There are no boring categories here. Even seemingly the simple ones, I've tried to pair up, like prisms. We did prisms. We didn't do anti-prisms. Okay, so I've paired those together. That's all one category. You'll tell me what makes a prism and an anti-prism and how they differ. So that contrast will be part of your presentation there. Frustums, very cool, very common shape, often overlooked, okay? Star polyhedra, they look amazing. Right? Stellated polyhedra look also amazing. Trapezohedra, that's a fun one. I think that one has actually been picked. So the official what has been picked already, because I want only one group per topic. That is on the group assignments there on the front page. So right, they've already got pyramids and bipyramids. I need to add in. You guys, the first group there, they already picked the trapezohedra. I need to add that in. Just got the message earlier. Okay, so those are taken, so pick something else. Any of these rest are up for grabs, right? You could do the cupolas, right? The bit that goes on top of the gazebo, right? Go for it. And then for each topic, your presentation must include this information. You must have a formal definition using all of the proper vocabulary terms. Definitions out of the textbook, but for your topic. Included with that, I also want you to give me an informal definition. Give me the simple version. How would you explain it to a 5-year-old who doesn't understand anything more advanced than polygon? Okay? Don't use any of those extra fancy terms, regular, irregular, convex, like, they don't know what that means, okay? How do you recognize this from the sea of all the other polyhedrons out there? What's the standout feature that you go, oh yeah, that's definitely a star polyhedron right there, spotted a mile away? These don't all have to be individual slides. Perhaps your how to recognize information is included as part of the informal definition. That's how you distinguish them, okay? So a lot of these can meld together. I just need to make sure you've identified that part. A big part of the presentation will be including many examples, at least 3 of your category with names and pictures. Right? This is a category. You've got all the specific elements of the category. If, for example, you had, nobody will because we studied them in class together, the platonic solids themselves, there's these 5. So give me at least 3 of them, give me their pictures and their specific names. Cube, here it is. Octahedron, here it is. And give me some non-examples. It's the other one. Tell me, why is this thing here not a platonic solid? Point out what makes it not fit that definition. Okay. And from one of your examples, give us the test of the old Euler's formula. Count up the edges, faces, and vertices, and check if Euler's formula holds true for your category of polyhedra there. Some of these categories, in fact many of them, also have subtypes. If that applies to you, if there are types of star polyhedra, then tell me what are they? How do you, brief definition, how do you tell? Okay. And at least one interesting historical fact about your category. And that could be maybe when it was discovered. I'll give you a hint here. Scutoid, super awesome type of shape. Very recent discovery. This is a brand new shape, came out within the last decade, okay? So that can be cool to point out. Named, some of them are named after people, like the Catalan solids, okay? Who's that guy? What did he do? Maybe they're really useful for something, okay? What are the applications? Frustums actually show up everywhere. Lots of things are built out of frustum. Geodesics, that's a really cool one. Have you ever played on one of those dome jungle gym things on the playground? That was a geodesic. Okay, you can point that out. Lots of them have great applications. Maybe, I don't know about the stellated one. Those just look really cool. If someone can find a building that is a stellated polyhedra, that would be amazing. All right, that's what you need in your presentation. And then here are the grading criteria. So as mentioned, both me and your peers will be grading you. I will be using this all-purpose rubric here on the next page, looking at your content, completeness, creativity, correctness, and communication, the 5 C's. That'll be most of your grade. The next biggest chunk of your grade is your teamwork score. This is your grading of how your team members said you did to contribute to the project. Did they think you actually did your share of the work? Okay? Did you communicate well? Okay, did you keep up with the emails, or did you just ignore everybody and do your own thing? Did you cooperate? Okay, how were you maintaining a positive work environment? Yeah, he did the work, but he was a real pain. Okay, kept insulting us at every move. It was a real troublemaker there, but at least he got the work turned in. Okay, that's going to give you a low score there. Okay, you got to at least be nice about it as well. Okay, so you will grade each of your team members. So this is your chance, right? People who bemoan the group projects because, every time I end up doing all the work, my teammates do nothing, give them a garbage score on the teamwork grade. I will take that into account. I'll give you the good grade, and they will suffer the points, okay? So everybody, that means you've got to do your part. This is a team effort, right? And then in addition, you all will be grading each other's presentation. So on Friday, you will actually give your presentation, no more than 5-10 minutes or so, for you just to explain your topic there. And then everybody will be grading you based on how they feel you covered the content, how well they felt you did the presenting, the speaking part, how it flowed. And the prop in this case is the presentation itself. Okay, so the prop is referring to your PowerPoint slides or your diorama or whatever visual aid you have going on there. How well was that constructed? Was it easy to look at and to follow from there? Okay. The last part of the grade, the fourth component, okay, 10% is you completing the student feedback for everybody else. So part of your own grade is you being a good audience member and you doing it. So it's not enough for you to have the perfect presentation, everybody thinks it's great, but then you cop out and you don't do anything for anybody else and you don't give them feedback. Okay? You gotta give everybody feedback. That'll be part of your grade for turning those in. Okay? Questions for the presentation? Is it only one of us talking or does everyone take a turn reading off the presentation? That's for you to decide. Okay, you can determine that as a group. If you find like, hey, I am happy to do more work of research and putting it together, but I'm not a speaker, you guys handle the speaky part. If that's how you want to divide up the work, go for it. Okay, as long as everyone agrees, I'm okay with that. Or you can, break it off and you do these 2 slides, you do these 2, these do these 2, whatever. Okay, other questions? Okay, then the last thing I want to show and talk about comes from the Polyhedra Viewer itself. Okay, some very useful resources for you. This website, in addition to having the visual aids on there, it's got information, detailed. It's got its own definition, so you can get your formal definition right from here. Right? What is a cupola? Alternating squares and triangles, right there. Okay. Even better, go down to the bottom because this doesn't have everything. Everything is not on this page. But wait, there's more. Okay, there's additional websites that are equally as awesome and cool. I really like this one, Visual Polyhedra by David I. McQueen. It's got the platonic solids here, and this has like all the 3D models on one page. Okay, and it's got, what are these? Kepler-Poisson solids. Those are cool looking. Okay, lots of categories. Here's the Catalan solids. Okay, maybe you pick that one. That's an interesting group to look at. So many more categories. In case you wondered, no. Even with all our project categories to pick from, we still haven't covered all the polyhedra. We haven't even covered all the convex polyhedra. Okay, here's prisms and antiprisms. Right, here's the dipyramids and the trapezohedra. Okay, here in pink, that's what those look like. Very cool. Little crystal shard kind of thing. Chamfered solid, Johnson solids. Page one, there's so many pages of Johnson solids. Oh my goodness. Okay, lots of things are Johnson solids. This one also has the geodesics. Okay, this is apparently is page 2. I skipped it. I don't know where page 1 was. Geodesic rhombic triacontahedra. Oh gosh. Oh, look at these things. Geodesic cubes. These are quadrilateral base geodesics. Very cool stuff. Lots and lots of other solids. Oh my goodness, right? It never ends. So play around with that. This is a great resource here. Another excellent resource, believe it or not, Wikipedia. Very good for math stuff. Very excellent for geometry because it has great visuals. Okay, here's lots of the categories. The star polyhedra right here. The Catalan solids, toroidal polyhedron. If you really insist on donut holes in your shapes, this is the one for you. All right there. Look at all of these crazy guys, okay? Different kinds, different pictures of everything. And really nice thing about Wikipedia, as you know, at the bottom they have the see also all the references. So here's just a giant list of good resources, external links. This would probably be a little easier to navigate than the footnotes. Even better, I love these down here where they group and categorize everything so you can find out what goes in what category. Okay, you can see the subcategories of everything. Where do the bipyramids are a type of dihedral uniform polyhedra. Okay, what does that mean? So this can be a great way to help you set up your definitions and how they compare to other polyhedra right here from Wikipedia. The only caveat I would warn you, Wikipedia can get very technical. It is often written by mathematicians for other mathematicians. So this can be a great source for the formal definition, but if you can't understand that definition, you're going to have a hard time translating it into the informal version. Okay, so be wary of that. This gets very technical, very in-depth, very precise, very good, but sometimes it can be a little too good for a high school level. Okay, I'll just put that out there. All right, so, but feel free to make use of that. All right, last call for questions before I send you out to your Zoom breakout rooms. No? Okay, first group, I have your pick of trapezohedra. I don't have one for the second group, so Janeely, Jonathan, Mariah, and Mark. Rooms are now open. First thing you guys need to discuss is which topic you want and send me a message back, okay? Go, get started, begin. Okay, and that will do it for